In this video, we're going to use matrices to solve linear systems in two variables. So we're going to start by defining something called row echelon form of a matrix. Row echelon form is when you have a 1 in the upper left corner, a 0 in the lower left corner, a 1 in the lower right corner, and then you have some number in the upper right, and on the right side of the vertical line, these are any number. So our matrix looks something like that, where the stars are just numbers. But the important thing is the placement of the ones along the diagonal line here, and then the 0 in the lower left corner. So when we're solving a system using matrices, what we're going to do is we're going to turn our matrix into a matrix that is in row echelon form. And this process is also called Gaussian elimination. So if you're looking up videos or Googling to help you with this concept, then that's a good thing to look up. So the first step in doing this process is to write the system as an augmented matrix, which we talked about in the last video. We are only going to be doing this with systems of two equations in two variables. If you look in the book, you'll see what it looks like. They do some examples with some three variable systems, but that's more complicated, so we're just going to do the simpler ones. So write the system as an augmented matrix. Then step 2 is to use matrix row operations, which we talked about in the last video, to change the matrix into row echelon form. And the steps for this, it's important that you kind of do these in the right order. The first step is to get the 1 in the upper left corner, if it's not already a 1. If it is already a 1, then you can skip this step. And for the problems we're going to be doing, there's going to be a 1 in the bottom row, so you can do this step by just switching the first row and the second row. Sometimes for some systems that won't necessarily be the case, but we're not going to do those because, again, I want to just kind of stick to the simpler problems here. So that's the first step. And again, if it isn't already a 1 in that spot. The second step is to use the 1 and the row operation of multiplying and adding two rows together, multiplying a row by a number and then adding it to another row to get the 0 in the lower left corner. And then the final step is to get the 1 in the lower right, and to do that, we always do that by dividing. So you're going to divide the bottom row. Remember, you can multiply or divide by a constant in row operations. Divide the bottom row to get the 1 in the lower right corner. So that's the process of changing the matrix into row echelon form. Once the matrix is in row echelon form, the bottom number to the right of the vertical line is y. And then we're going to plug into the top equation. So for this step, we're going to put our matrix back into equations. And then plug in y, or you could plug in to one of your original equations too. That should work also to get the x coordinate. And then remember, we're writing our answer as an xy coordinate pair. So we're going to look at example 2. It says use matrices to solve the system. The notes that are posted online, I try to write out more of the thinking process behind this. I'm not going to write all that stuff out right now just to kind of save time in the video, but you should look at the notes to see what the thought process is. I'm just going to explain it verbally here. So first step is to write the system into the matrix like we talked about before. Make sure that you keep negative signs if there are any. Now the first thing that I need to do is change the 4 into a 1. And the way that I'm going to do that is by switching row 1 and row 2. Because I see that row 2, I have a 1 right there in that first column, so I'm going to switch those 2 rows. So this is going to move the 1, 2, -1 up to the top, 4, -3, -15 on the bottom. So that's the first step. Again, if this was already a 1 on the top, then I wouldn't need to do that, but in this case it was a 4, so I need to switch those 2 rows to move the 1 to the top. Now the second step is to change the 4 into a 0. So what I need to think about is, what do I add to 4 to get 0? I need to add -4. So what I need to do is multiply row 1 by -4 and add that to row 2. So again, when we do this operation where we're multiplying a row by a number and adding it to another row, my top row is not changing. So I'm not changing R1 here. I wouldn't want to do that because that would make this 1 into a 4, and that would be undoing the step that I already did. So what I'm going to do is multiply everything in row 1 by -4 and add that to the number that's already in row 2. So this is going to be 1 times 4, or 1 times -4 plus 4, 4 plus -4, which is 0. In the second position here, the lower right corner, I'm going to have -4 times 2, which is -8, plus the -3, which is already there, is going to give me -11. And then to the right of the vertical line, I'm going to have -4 times -1, which is +4, plus the -15, which is already there, which is also -11. So that's what the matrix looks like after that step B. Now, what should always happen at this point is you should find that when you divide, in order to get the 1 in the lower right, I would divide that by -11. The number to the right here should also be something that's divisible by -11. In this case, it's also -11, so I know that it is going to be divisible. But my next step is to get the 1 in the lower right, so I need to divide row 2 by whatever is in that lower right corner. In this case, -11. So this is going to be 1, 2, top row's not changing. 0 divided by -11 is 0. 0 divided by anything is 0, so that should keep the 0 there in that place. -11 divided by -11 is 1, and it's 1 over here too. So again, you should always get a whole number here when you divide this row. It might not necessarily be 1, but it should come out to be a whole number. Now, I have the 1, 0, 1. I'm going to put this back into equations. So it's going to be, remember this is x y equals, so it's going to be 1x, or just x, plus 2y equals -1. Now for the bottom row, this is 0x plus y equals 1. 0x is just 0, so this can be simplified to just y equals 1. And now that I have the y coordinate, I can get the x coordinate by plugging in. So I'm just going to plug into this top equation that I have right here, although again you could also plug into one of your original equations. You should get the same thing. So x plus 2, plug in 1 for y. 2 times 1 is 2, and then to get x by itself, I need to subtract 2 from both sides. So that gives me a value of x equals -3. So again, in my math lab, we're going to type this as a coordinate pair, x comma y. So that's the answer. Now, what you should try to do next is checkpoint 2. Do this in your notes. Check your answer with the notes that I have posted. Again, in the notes that I have posted, I tried to write out the thinking process for this, just so that you could get a better sense of it. So read those over, find other videos that go over this concept and see if it helps to watch other people explain it, and you can post those in the discussion board for this week as well. So once you do this checkpoint, then you should try the homework problems.